Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with the topics on the PE Civil exam. So this will be our first problem in the structural statics series. And what we have going on here is we have this ideal truss shown below that is supported by pin connection at D and a roller at C. Loads are applied at points A and F as shown. What is most nearly the force in member DE? So we are looking for this force member right here. So since this member is touching the reaction down here at point D, let's go ahead and let's find the reaction here at D. And our reaction here at D, we would have a vertical and a horizontal, which I'm only really concerned about is the vertical, because if we look at joint D down here, we have a horizontal member and a vertical member. So the horizontal will resist the horizontal reaction and the vertical will be opposite to the vertical reaction. So really the only thing I'm concerned about here is this vertical reaction, which will be opposed by member ED. So let's go ahead and let's find the reactions, the vertical reaction at D. So what I'm going to do is I'm going to sum moments about point C equal to 0. So I would have my 1600 here multiplied by the vertical distance to get it down, which is 16. And then I'm going to have, that will be counterclockwise, so it'll be positive. And then I'm gonna have clockwise rotation of the 8,000, so minus off 8,000 times its horizontal distance over to C, which is 6. And then I'm assuming that my dy is going upwards here, so it will be swinging counterclockwise about C, so it'll be plus dy times its perpendicular distance over to C, which is also 6, and everything here is unitless because units were not given. And this will be equal to 0. So solving this, dy, my reaction at dy is 3,733.3 in the upward direction. So looking at joint D here, what I would have is I would have my reaction at 3,300 or 3,733.3 in the upward direction. I have an unknown from CD, my unknown reaction of D sub X, and then I have my ED here, which if I sum forces in the vertical direction, everything has to be in equilibrium here at joint D, including all the forces on joint D and all the members connecting in. So if I sum forces in the vertical direction, that means that my DE force must be 3,733.3 in the opposite direction to the reaction. Now, it says here what is most nearly the force, and you got to love when they have problems like this because you always have to do a little bit of rounding. So what is the closest force that is given here to my answer? Well, it would be D here, which is 3,700, which is the closest to my actual value that I calculated of 3,733. And that's how you would solve that particular question. You just have to watch out with these types of exams, which if you are taking the PE exam, you most likely took the FE exam. So you are familiar with this type of wording here. Just got to be careful with it. So I hope this video is helpful. And if you want to see more problems solved this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel. Also, good luck with the PE exam. Thank you for watching, and I hope you have a fantastic day.